Hey guys, welcome back to my series where I'm going through all the challenges in my book, The C Sharp Player's Guide, and solving them. We're on this countdown one for this video. I just want to point out that this challenge is like it's in the side quest. So if you're having a hard time with this one, like recursion is a tricky topic. And I think it's important to be familiar with the idea that there's this thing out there called recursion that a method can call itself. And if it does that, then it has to like be getting closer to an answer. And as long as you're like aware that it exists, that's especially if you're new to programming, that's all you really need out of this. If you're a veteran programmer, recursion is not going to be that weird or surprising to you, and that's fine too. If you're somewhere in the middle, it is. There are some things that just have a recursive solution is just super clean and elegant compared to like a loop based thing. So it's an important tool to get familiar with. It's not a tool that you have to learn in your first year of programming though. So anyway, just a word of caution. Like if this whole section was confusing, it is a side quest, and this is like the only challenge in the whole book that is in a side quest. I tried to avoid doing that. I just didn't feel like I could pass this one by. I thought this was too useful to do. So anyway, let's look at this. So these people are saying there's these people, they've been told, like writing appearing on the tomb of Algo the Wise. There is this like words that appear that say that they'll be that the next true program will be able to write any looping code with a method call instead. So he says, here's this code. It's a simple for loop. Write that with recursion. Now, obviously, we're going to need methods to do that. So that's what we'll do here. I'm going to copy this for now. We'll just count down from 10 to 1. And yeah, let me delete this other code here and put that in just for reference. So we know we're going to need we need a method, and it's going to be a recursive method. So what we want is something that can count down from 10 or whatever the number is. If we think about this, like one way that you can deal with recursion is to start with like, what is the most dead simple version of this that could possibly exist. So if we say we're going to have a method that's like void count down. And the simplest thing this could be is we're supposed to count down from 10, including 10, down to 0, and stop at 0. In fact, we're not supposed to, like if you look at this code here, this stops. It bails once it reaches 0. So it'll display 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, but not 0. So what we can do here is we could say, well, I'm missing something, and that is the number. That's the number to count down from. So I could like put this in here. In this case, we'd maybe make this be number. And now we could count down from 5, or count down from 10, or count down from 100, right? Anyway, so we don't want the loop though. We want to get rid of that. So, but let's suppose, so if the number is 10, is the number is 0, we're done. We don't have to do anything else. So that is the base case, is if we are at 0, there's nothing else we need to do. But what if it's anything else? So like we could say, well, if the number is 1, then we could say console.write line the number, and then we return. And I could do this again. If number is 1, console.write line, number is 2, write line number console.write line number -1 return. So this will write out 2 and then 1, or if, I mean, we could write it out as that. Anyway, like we could do it this way. Obviously, like, why not use a loop if we're going to do it that way? It would shorten this by a lot. I mean, we had 2 lines for that for loop, but the pattern to recognize is 2 is the same thing as 1, only it just writes a 2. It writes a 2, and then it does everything that countdown with a value of 1 does. So we could, well, let me go one step farther here. So if the number's 3, just so the pattern's just a little bit clearer. Same thing here, like the 3 does everything 2 does, but it displays a 3 first. So what if in here we said do everything the 3 does and then count down with 2. And with the 2, we said count down with a 1. And here we said count down with a 0. So now if it's 3, it'll come in here and it'll call the same method again, and then it'll come into the 2 case, and then it'll go into the 1 case, and it'll go into the 0 case, and then it'll be done. And we could obviously keep doing more and more of these. We could do number equals 4, number equals 5, but hopefully maybe at this point you can start to detect, like, there's definitely a pattern here. Whenever we're doing this, it's just going to be we display the current number, and then we just call countdown again with, you know, the next number down from us. So like all of these, well, I could actually get rid of that at this point. All of these fit the same pattern, and all of them are number -1, number -1, number -1. And I mean, at that point, it's like they're all the same. There's no need to do if number is 1, if number is 2. So at this point now we can just say they're all the same. So let's just clean this up and leave it at that. And that's the whole thing. I'm not sure I'd say that that's usually how I like come up with a recursive algorithm. It's like writing it out like that and then condensing it, collapsing it. It is a way you could do it. But really what we need for a recursive solution for something like this is you need some base case that says that once we get to here, we stop. And then you need obviously there's going to be some work that you have to do. That's this line here. But then you always need to like be moving toward the base case. So in this case, like, no, if the number was 88, it's just going to move down 87, 86, 85. If the number was 999, it'll be 998, 997. It'll, no matter where it is, as long as it's a positive number, it'll work its way down to 0 and then it'll end. So that's really, it requires a paradigm shift, and it really does take some getting used to. Like I said, at some point for most programmers, you beat your head against recursion for days, weeks, maybe months, and after fighting through it for a long time, all of a sudden it just kind of clicks, and you're like, oh, I think I get it. And then after that, it just starts to be a lot easier to write recursive code. Now, is this code better being recursive rather than like a loop? I don't know. I don't really think so. There are people out there who are going to say that it definitely is. I'm not one of them. I kind of like the for loop. Like, that's pretty, and maybe it depends on what languages you're familiar with and you know what languages you've spent most of your time in. There are some languages out there that don't even have a loop construct because they expect you to use recursion for everything that you would use a loop for. So you can always write a loop using recursion. That doesn't mean you should. It just means it's a possibility. Like I said, some algorithms are just well suited to recursion. That it's just the code looks way better when you use recursion. Let's run this and make sure that it actually is going. So we did countdown from 5, 4, 3, 2, 1, and then 10, then 100. That all looks good. Anyway, like I said, it's a tricky subject. I wouldn't worry about it too much if it isn't making, especially if you're relatively new to programming and it just isn't making sense. I wouldn't stress about it too much. Other than someday down the line, you'll want to get good at it. Just because, like I said, there's just so many things out there that are just better off with that, with having that as an option. But it does not need to be today. There's a reason it's a side quest. Anyway, I think that's it for this one. I will just keep it short and simple. And I see you guys next time.